Welcome back to Sciencepect. Today, we're embarking on one of the most incredible journeys in human history, the digital revolution. It's the story of how we moved from mechanical gears and vacuum tubes to the interconnected digital world we inhabit today. This transformation didn't happen overnight. It was a century-long march of innovation, leading us into the information age. Our story really begins long before electricity. Humans have always needed to calculate and process information. Early tools like the abacus and later mechanical calculators by Pascal and Leibniz were steps towards automating computation. But the true dawn of the digital age required a fundamental shift. The idea of programmable machines. Visionaries like Charles Babbage, in the 19th century, designed incredible mechanical computers like the analytical engine, a concept remarkably similar to modern computers with input, processing, memory, and output. His collaborator, Ada Lovelace, is often considered the first computer programmer for her algorithms intended for this machine. However, the technology of the time wasn't ready to fully realize these complex designs. The real breakthrough came with electricity and electronics. The mid-20th century saw the birth of the first electronic computers. Machines like the Atanasoff-Berry computer explored fundamental digital concepts. But the most famous early example is ENIAC, completed in 1945. It was colossal, weighing 27 tons, filling a large room, and using thousands of vacuum tubes. Programming it meant physically rewiring it. These early machines were primarily for complex scientific and military calculations. The 1950s brought a game changer, the transistor. Invented at Bell Labs, transistors were smaller, faster, more reliable, and consumed far less power than vacuum tubes. This invention was monumental. It led to the development of smaller, more powerful computers, ushering in the second generation of computing. The next leap was the integrated circuit, or microchip, in the late 1950s. By etching multiple transistors and other components onto a single silicon chip, engineers could create even more complex and powerful circuits in a tiny package. This invention is perhaps the cornerstone of modern electronics. Building on the integrated circuit, the development of the first microprocessor. The Intel 4004 in 1971 was revolutionary. The first time, the central processing unit of a computer could fit on a single chip. This dramatically reduced the size, cost, and power requirements of computers, making them accessible for a much wider range of applications. The microprocessor paved the way for the personal computer revolution in the late 1970s and early 1980s. Companies like Apple, Commodore, and IBM released machines affordable enough for individuals and small businesses. This wasn't just about crunching numbers. It was about empowering individuals with computing power for tasks like writing, counting, and eventually communication. The graphical user interface was popularized by Xerox PARC and later Apple Macintosh and Microsoft Windows, made computers far more intuitive and user-friendly. But the digital revolution wasn't just about individual machines. It was about connecting them. The seeds of the internet were sown in the late 1960s with ARPANET, a project funded by the U.S. Department of Defense. Its goal was to create a decentralized network that could continue to function even if parts of it were destroyed. Key concepts like packet switching, where data is broken into small blocks that can travel independently across different paths, were developed here. While ARPANET was crucial, the internet as we know it today exploded in the 1990s. Largely thanks to the creation of the World Wide Web by Tim Berners-Lee at CERN in 1989, he developed HTTP, HTML, and URLs, the fundamental technologies that allow us to access and navigate information using web browsers. The release of web browsers like Mosaic and Netscape made the internet accessible and understandable to the general public. The dot-com boom of the late 90s and the subsequent developments in broadband internet access. Wireless technology and mobile devices transformed the web from a novelty into an indispensable part of daily life. The rise of search engines like Google, e-commerce sites, social media platforms, and streaming services reshaped industries and human interaction on a global scale. Today, the digital revolution continues at a breakneck pace. We're seeing the integration of computing into almost every aspect of life, from smart homes and wearable tech to artificial intelligence, big data analytics, and the Internet of Things. The processing power available in a modern smartphone dwarfs that of the early room-sized computers. From Babbage's dreams and ENIAC's massive scale to the global network connecting billions, the journey of the digital revolution is a testament to human innovation and our drive to calculate, communicate, and connect. It has fundamentally changed how we live, work, and interact, ushering us fully into the information age. What part of the digital revolution fascinates you the most? Let us know in the comments below if you enjoyed this deep dive. Please give us a thumbs up and don't forget to subscribe to Sciencepect for more journeys into science, technology, and space. Thanks for watching. See you in the next video.